Hey, welcome back. I will be going over some simple utilities that have made life a little bit easier when developing in Unity. So, just to give you a show of we've got an animator utility, a debug utility, nav mesh utilities, transform utilities, and vector3 utilities. These are all something just to aid development and shortcut a lot of the checks that you would do or you would want as you are developing. The animator utility, I'm not going to spend too much in this. I did do another uh, Unity animation video prior to this, so that should be covered there in very good detail. In fact, I would highly recommend to go and have a look. But very simply, since you're here, if you don't want to bounce around videos, the animator utility, we have a way to store some animation hashes and some execute hashes. These are for the purpose of managing animation states, as well as when a method has triggered for an animation. We've got just some helper methods for set current hash and get current hash. We can even call this manually outside. These are all static classes, so every single one of these are static, so we can call them anywhere. Execute method during animation. This will execute a method during an animation. If you haven't watched the other video, let me quickly show you what that looks like over here. So during our attack, at halfway through our animation, animation, we're going to call the damage if valid range and target. This is within our update loop, so we will hit this once we reach that normalized time of the animation. Then we have crossfade or play. Crossfade or play, let's go back to that attack animation, is an improved way of crossfading that handles the checks you would need to determine if the animation state has changed or not, to be able to perform the same or different animation while crossfading at the same time. Once again, detailed in the animation video, so I'm not going to spend too much time on this. Simply, it is checking for the current state, and if the current state is the new state, the animator cannot handle that appropriately. So we're doing the handling of that for it, and we'll be able to play our animation. All right. Debug utilities. This is some very fun and easy stuff. I do have these scattered around, but I've just commented them all out. There's this log method. Essentially, what it does is wherever you call it, say, for example, if we were to call it in our patrol state, we just call debug utility log method, and what that will do is it will show in the console what method and class name it was called in. So you don't have to pass in values and parameters and configure the string notation in order to give you exactly what you want. If you just need a quick and dirty, just tell me what method and what class, so I know that it is hitting that point. You can simply use this for that. Obviously, it doesn't take any parameters, so it will not actually give you anything more detailed than just saying exactly that. Then we have this draw box. It's just a way of drawing when you drawing a box by passing in the box parameters and a color. Useful if you are not using a mono behavior method, because in order to use a gizmo is probably what you're used to when you're drawing debug things. The draw box kind of goes around the need to have it in a mono behavior, as it simply uses a debug.draw line and it draws all the lines to form the box. Yeah. Next we do have handle error if null get component. These are a bit cumbersome. I started with them because they were actually provided from the Unity demo first-person shooter level. They were useful to begin with. I think there are better ways to handle this, especially because it is not as easy to use. I kind of have to always come back here and wonder what is TO, what is TS, how does it actually work? The idea is that whenever you are calling a get component, let's go to this projectile standard. So we're trying to assign a projectile base component to this, and we are calling a debug utility dot error if null get component. So we have our projectile base, that's the type of component on this type of object that we are calling it in this class, projectile standard, and the variables that belong or where they're supposed to be assigned. So projectile base, that's the variable that's supposed to have the projectile base. The source is this script, and as well as we provided a game object so it can tell us a little bit more about where this is being called. So that's what these are. There is a handle error if null find object, if you're using find object, if no component found, or handle warning if duplicate object. So you're trying to add an object and now you've got more than one. You can find out if you've got more than one. So that's what these do. You can find them, like I said, in the demo level if you wanted to have a look at it in a bit more detailed. Check out the Unity FPS demo and look at the debug utility. All right, nav mesh. Oh, this is a very good one. If you want to know if an agent has reached a destination, you often have to check, is the path still pending? Is the distance within the stopping distance? Or otherwise, has the path being reset, so it no longer has a path? Or the velocity of the agent is also 0. So it either doesn't have a path or the velocity is 0 to say that it has stopped. We will then return a boolean of has reached destination. This is used in quite a few places. For example, we're patrolling between points and we want to know, has the nav mesh agent actually reached its destination? If so, then let's go back to the new, let's select a new node to then patrol to, and then we can set the destination. Look at that. That's not the typical. So typically you would see agent.setDestination and you just set the position. It takes in a position vector. In this case, set destination sampled, so it returns the same boolean as you would with set destination. So that's part of its signature. Except we're doing a set destination sampled, and what this does is that we are setting the destination for the nav mesh agent, but we are also we're going to sample that destination. We are so the target position, or the destination vector 3 that you want to go to, it is then going to perform an area check or a distance check to say that, okay, you know what, is that position valid? If it is not valid, look up to whatever the sample distance is. So think of a circle in the center, and we're propagating outwards by some distance to find a valid point that is on a nav mesh. Now the nav mesh is going to check all nav meshes, but you can change the area mask to be a particular nav mesh. And then once we have a valid hit, so sample position returns a boolean. If we get a valid hit, we will then set the destination to that hit.position. So that's what set destination sampled does. It just does an initial sampling of the nav mesh to check that if it is valid. So that is it for the nav mesh utilities. Next we've got some transform utilities. These ones pretty good. to have. I have not leveraged them. This was actually taken from git-amend has a video on, so git-amend is a YouTube. He's got a video on extension methods. This is where this was grabbed from, the extension methods. Very, very handy when you need to deal with children or just trying to extend your transform. So we're extending transform and we are essentially performing an action that is either destroy all children, so you can just call, let's go into something that says, let's go, please state, on enter, we can, so it is a modification to a transform. So we have a target over here. Let's go, underscore target, not dot position, dot destroy children. So that is calling this because it is extending it. So we can now, just from the reference of this transform, destroy all its children without having to do an iterative check in all the children and find and start handling that, because we know that we want to do it from a transform, because that is the root point of the object, and we can start doing children checks or parent checks from them. It's just a neat way of handling it. All right. Next, we have the transform. We've got destroy, enable, disable, perform action. You can add more if you want to perform a certain action on the children. So this is perform action on children. You can extend this to perform action on parents, or do more transform manipulation if you need so. Next, we've got vector 3. These are also, once again, from git-amend. I've not utilized them yet. I'm sure they are useful once I actually get around to it. So once again, that same video has got width and add, and it allows you to do things such as you have a vector 3. Let's go, let's just go vector 3 target position, and you can do target position dot width x0. So you can say that let's see, new position, or you could do a transform on it, say some calculation, distance check if you wanted to. So vector 3 dot distance, and we just throw this guy in there between one location and target position with y. So you can say that, okay, this target with its entire vector values, so y and z are exactly what they were originally. However, in this case, we're saying, you know what, x will be 0, or y will be 0, and leave everything the same. So that's very handy. Otherwise, you would have to create a new vector 3 and essentially apply a new set of values, because vector 3, as you can see, it is a struct. So you have to instantiate a new struct and reassign the values. With this, it is essentially doing that, but it's internalized it. So we are generating still a new vector 3. We're still using a new vector 3 by adding vectors and checking for null vectors. But yeah, those are just some extension methods I thought I'd just show you because they can be very helpful. Yeah, I think that's it for utilities. There is, oh, we've got a Gizmos utility. Sorry, I missed one. That would have been very, very, very sad if we didn't see them all. All right, Gizmos utility. It allows us to easily draw a circle by giving it a center, a radius, and some segments. Draw a cone. This is a bit of a monster because it requires a few other things like drawing the FOV arc and drawing a vertical arc. So, and getting the FOV points. So all this is just so that we can draw a cone. But by having it as a public static method, we can actually see where this is used, and this is used in our line of sight script, which is very easy. So we just want to simply draw a cone instead of having that bulk amount of gizmos that you usually have at the bottom of your scripts. You have gizmos, utility, you have some very common things that you draw with it, and then you just call them. So draw cone, pass and transform, horizontal, vertical, and the view distance. And I can actually show you what that looks like very easily. So this guy, this is using all those vectors. So that is our field of view. That is our field of view. That's the arc. That's the circle. The draw circle. Yeah, just a very easy and handy way of uh, of managing that. So that's everything. I hope some of this comes in useful. And yeah, thanks.